Hello everyone, and thanks for joining me on my talk about designing telepresence drones to support synchronous media remote collaboration. My name is Mehrnaz Sabet, and this project was a collaboration with Dr. Mania Orand and Dr. David McDonald. Drone technology has continuously been evolving in recent years with exceptional growth in data collection, supply delivery, and farming. During the pandemic, drone technology has been used in a range of novel applications such as disinfecting spaces and controlling borders. Despite the recent growth in using drone technologies for telepresence, existing telepresence drone platforms do not support remote collaboration and social interaction between multiple remote users. In addition, these technologies do not give the remote users the freedom to control and manage the drones without relying on an on-site drone user. So we undertook this project to understand how can we design a drone-based telepresence system to support remote collaboration. We designed and developed Squadrone, an aerial drone-based telepresence system that supports synchronous media collaboration among multiple remote users. Squadrone is a complex configuration of different technologies consisting of a drone as its core, a 360-degree camera that is mounted to the drone with a smartphone that connects to Squadrone's server, the interface that connects remote users to the drone and allows them to collaborate over the shared visual space, and finally, the remote users are equipped with programmed game controllers and VR goggles to explore the view and control the drone. We mounted a 360-degree camera to the drone to see if an aerial 360-degree view can benefit remote users in their collaborations while giving them independence in where to look at when they are connected to the same drone. Remote users can explore the view live streamed from the mounted camera to the interface using VR goggles. Remote users can communicate over the shared visual space using the voice conference call feature. They can also collaborate in controlling the drone using their programmed game controllers that is managed through the user interface. Squadrone's UI is a web application that consists of three main pages: an interactive map with drone locations, flight customization, and connection to the drone. Here is a video that shows the system in action. The remote user connects to the drone and places the phone inside the headset to explore the imagery. This is the user's view of the environment. Meanwhile, he is controlling the drone using the programmed controller. Other members of the same flight are also exploring the environment using their independent views while collaborating through a web call. Current drone pilot passes the control to another member with the controller. The new member is now in control of the drone. We evaluated the Squadrone through 3 design iterations with 13 participants. In design iteration 1, our goal was to evaluate the basic functionality of a Squadrone and to study how participants would interact with the shared visual space. Then in design iteration 2, our goal was to understand how participants might experience telepresence in a type of collaborative exploration task over the shared imagery. Finally, in design iteration 3, our goal was to evaluate mechanisms for flight handoff and collaboration between remote participants and to see whether this type of active collaboration would impact members' participation in a kind of search task. Our results suggest that first, drones have a great potential as a platform for remote collaboration. In addition, collaboration over a shared aerial 360-degree visual space enhances social presence for multiple remote users. Also, participants developed a shared mental model to be able to point and reference objects in the environment and to give directions to the drone pilot. As a result, the participants developed a better situational awareness as a group, which could lead to a more effective search strategy. Also, when users have agency in controlling and navigating the drone, they are more engaged in performing the tasks and collaborating with each other as opposed to automated flights. Finally, the ability to collaborate and communicate with other members of the team, combined with the 360-degree aerial views, were the key factors that contributed to the participants' sense of being there. So to summarize, our main contributions are: a drone telepresence platform that supports synchronous remote collaboration using a novel shared 360-degree display, enabling remote users to pass the control of the drone to other remote users while collaborating on a task, and design insights for future drone-based telepresence systems that support remote collaboration, and finally, reflection on a telepresence design framework and extending it to address the challenges identified through this work. Thank you for your time.